Types of addition polymerization mechanisms. Explain the use and role of Ziegler-Natta catalyst in addition polymerization, and classify polymers as thermoplastics, thermosetting plastics, or elastomers. Polymerization can proceed by one of the three mechanisms shown. All three mechanisms have three common stages. Click Stages. For free radical polymerization to occur, an alkene must be heated with a radical initiator. Ethene, for example, polymerizes to form polyethene in the presence of dibenzoyl peroxide, which acts as a radical initiator. Click the Initiation button. Now click the Step 1 button to view the formation of the phenyl radical in the initiation stage. Click the Step 2 button to view the formation of the phenyl ethyl radical. Click the Propagation button to view how the chain is propagated. Now, click the Termination button to view how the chain process is terminated. For cationic polymerization to occur, the monomer should have electron-releasing substituents, alkyl groups. For cationic polymerization, the initiator is a Lewis acid such as aluminium trichloride or boron trifluoride. Click the Initiation button to view the formation of a carbocation. The electron-releasing substituent stabilizes the carbocation formed by the alkene. Click the Propagation button to view how the chain is propagated. In the propagation step, the cation formed reacts with a second monomer molecule, the new cation formed reacts with a third monomer, and so on. Click the Termination button to view how the chain process is terminated. The polymerization can be terminated by the loss of a proton or by the addition of a suitable nucleophile that can react with the positively charged propagating site. For anionic polymerization to occur, a strong base is needed. A good monomer for anionic polymerization should contain at least one strong electron withdrawing group, such as a carbonyl group, a cyano group, or a nitro group. Click. Polymers formed from addition polymerization with substituted ethenes as monomers can show three possible stereochemical configurations, namely atactic, syndiotactic, and isotactic. Click on the isotactic, syndiotactic, and atactic buttons in turn. Isotactic and syndiotactic polymers, with their side groups positioned in a regular order, have regular packing arrangement. They are stronger than atactic polymers. Ziegler-Natta catalyst is an organometallic complex often containing titanium and aluminium. It was discovered by Ziegler and Natta that the stereochemistry of a polymer can be controlled if the incoming monomer and the growing end of the chain are coordinated with Ziegler-Natta catalyst. The presence of Ziegler-Natta catalyst results in either isotactic or syndiotactic polymers which are linear. As a result, polymers with improved properties such as higher density and greater strength can be synthesized. Summary: a Ziegler-Natta catalyst is an organometallic complex often containing titanium and aluminium. The presence of Ziegler-Natta catalyst results in the production of addition polymers that have improved properties such as higher density and greater strength. In general, polymers are classified into three major categories depending upon their physical behavior. Click on Thermoplastics. Thermoplastics are polymers that are hard at room temperature, but they become soft and viscous when heated. This is because there is no cross-linking in thermoplastics. The individual polymer chains can slip past over one another in the molten form. Thus, thermoplastics can be molded into items with different shapes. They can also be melted and recycled. Thermosetting plastics are much stronger and rigid compared to thermoplastics. Click Thermosetting plastics. There is extensive cross-linking in thermosetting plastics. This reduces the mobility of the polymer chains and make the plastics brittle. Thus, thermosetting plastics can be molded only once, that is, when it is produced for the first time. Click on Elastomers. Elastomers are polymers that have the ability to return to their original shape after being stretched or distorted. This is because they have a small degree of cross-linking between the chains. Summary: polymers can be classified into three categories depending upon their physical behavior: thermoplastics, thermosetting plastics, and elastomers. Thermoplastics are hard at room temperature but become soft and viscous when heated. They are moldable at room temperature. Thermosetting plastics are much stronger and rigid compared to thermoplastics. They are highly cross-linked. Elastomers have the ability to return to their original shape after being stretched or distorted.